Hi, I'm Carl Hose from the Lincoln Electric Welding School, and I'd like to welcome you to another masterclass workshop for ARC Magazine. Today we're going to be talking about preheat prior to welding, especially when we're working on steel. And we're going to talk about what preheat is, why we do it, when we do it, how we apply it, how we measure. We always want to make sure we're working safely when we're working around welding and torches. I refer to ANSI Z49.1, safety in welding, cutting, and allied processes, which would include heating. Make sure we have our proper safety gear on, flame retardant clothing. Make sure the pants aren't frayed, your jeans, if you're wearing jeans, are not frayed. Gloves, proper safety glasses. Refer to manufacturer's guidelines for proper torch setup and application. Make sure we have the correct check valves on the torch, flash arresters back at the regulator, hoses are in good condition, regulators are set and operated properly. Today for our demonstration we're going to be preheating with a Harris oxy-fuel torch and a Harris regulators, and we have flash arresters on the back. We also have check valves on the torch. For our demonstration we're going to be working with a model that we made of a connection on a high-rise building. We're going to be using some tools to measure out where we're going to preheat and marking that with a soapstone here. And we also have a temp stick to measure the temperature of the steel prior to welding. Also going to be using a striker and torch here to light up the torch and go through the lighting procedure to light the torch to preheat the steel. Preheat is the temperature that we heat steel prior to welding. We don't always have to preheat steel. Most things that are built to be welded on are made out of very weldable steels, low carbon. A lot of times it's thinner sections and preheat's not required. But other times we're on jobs where the code dictates that something would need to be preheated, or we're welding on a steel that's higher strength level, higher yield strength, higher tensile strength, thicker sections, and preheat might be required. The primary reason for preheat is to slow the cooling rate of the area underneath the weld. When we heat steel up to a high temperature, it allows carbon to move in that area under the weld. And if it cools slowly, that carbon gets a chance to move back out and the steel can go back to a normal state. But if it cools too rapidly, that area under the weld can become hard and brittle, and that could lead to cracking. So heating the steel up prior to welding allows the metal to cool down slowly underneath the weld. And this is especially important as the material thickness goes up, like about 3/4, 1 inch thick, and as the alloy content or carbon content increase in the steel. The slower cooling rate also allows hydrogen more of a chance to diffuse out of the metal, and hydrogen sometimes, especially on thick restrained sections, can cause cracking in welds. Preheat also can help reduce residual stresses and reduce distortion, and also ensure mechanical properties such as impact properties are up to their requirements for the code. Today we're going to be working with the AWS D1 code. The model we have today is a structural connection on a high-rise building, and in that code book, table 3.2, there is some pre-qualified preheat and interpass temperatures for different grades of steel and different thicknesses, and we're going to follow that guideline today to demonstrate how we're going to preheat this part. This is just a mock-up, and we're going to kind of look at this and say this is a girder connection that's an A992 steel, and this column connection would be probably typically an A572 grade 50 steel. Now often these steels can be quite a bit thicker than our model is here. This A572 grade 50 column could be up to 5 inches thick in some cases on the bottom of a high-rise building, or it could be as thin as what we have here that's 1 inch thick. So we're going to refer to the code book and see what kind of preheat we need for different thicknesses of steel, and we'll also discuss what part of this gets heated for each one of these weldments. We're also going to discuss a little bit about interpass temperature, which the minimum interpass temperature is the same as the minimum preheat temperature. So when we're making a multi-pass weld, which you would have to do on a piece of steel over 1 inch thick like this, might take 4 or 5 layers of weld here. We have to check in between passes to make sure we're above the minimum preheat temperature. And in some cases, we also have to check interpass temperature to make sure we're not exceeding an upper temperature also. So when we refer to table 3.2 of the code book, category B is welding with low hydrogen welding processes. That would be electrodes like a 7018 or possibly processes like flux core arc welding, gas metal arc welding, gas tungsten arc welding, submerged arc welding. Those are all low hydrogen processes. And these particular grades of steel, the strength level of steel, actually, if the steel was under 3/4 of an inch thick, the minimum preheat's only 32 degrees. So if it's 38 degrees, it wouldn't require preheat. But if the temperature outside is below 32 degrees, the steel would require a 70-degree preheat to slow that cooling rate. As the steel gets thicker, from above 3/4 of an inch thick all the way through 1.5 inches thick, the preheat is only 50 degrees. Again, if the ambient air temperature outside is above 50, no preheat would be needed. But as the steel gets thicker and we go above 1.75 inches up to 2.5 inches thick or through 2.5 inches thick, the preheat goes up to 150 degrees, and above that the preheat goes to 225 degrees. For our demonstration, this column is only 1 inch thick, but we're going to assume that it's 1.75 inches thick. It would just been a little bit too big to use an 1.75 inch column in here for a model. So we're going to pretend it's 1.75 inches thick, and we're going to heat it that way. And we're going to measure it with a 150-degree temp stick. So I have the temp stick right here, and it's marked 150 degrees. This temp stick will not melt until the steel is 150 degrees. So I can mark it ahead of time and heat from the other side and watch the temp stick melt. That's what we're going to do. I'm also going to refer to the code book. We're going to mark out an area about 3 inches from the weld in all directions of the weld, because that's what has to be preheated, and that means all the way through the thickness. So if this was a 5-inch thick flange on a column, we would have to heat all the way through that 5 inches. Normally, if the material's under 3 inches thick, the preheat area is 3 inches in all directions of the weld, all the way through the material thickness. If the steel is over 3 inches thick, then we heat out as far as the thickness of the material. So if it's 5-inch thick material, we'll heat 5 inches away from the weld in all directions of the weld. And we have to maintain interpass temperature, minimum interpass temperature between passes as we go. So as we're welding this part out, we would have to continue to check our interpass temperature as we're welding. We're going to determine where we preheat. I like to mark out the area, approximately where we're going to be heating. It's nothing real accurate. We can go a little beyond that. So I'm going to go about 3 inches out from the weld this way and put a little soapstone mark, and approximately 3 inches up this way from the top of the weld. Almost takes me up to the top of the plate here. And that would be all the way through to the back side and also down here on the bottom. So this whole area would kind of need to be preheated. Also, you know, I'm going to go back on the back side about 3 inches here and on the back, and we'll mark that up. And then we're going to check it with a temp stick as we warm this part up. Now, I'm going to mention again, earlier I mentioned that this would be welded with a low hydrogen process. Typically, high-rise construction on a big building, they would use a semi-automatic process like self-shielded flux core. And the flat position T-joint here, which is a bevel groove joint, would be welded with a 70 T6 wire, such as a NR 305, usually a 5/64 or 3/32 size. That would be the fastest way to weld these flat position welds. And the vertical weld, if this is welded around on this shear plate here, would be welded with a 71 T8 wire, like an inner shield 232 or 233. Usually a 5/64 or 0.72 diameter would be used on that weld. It could also be stick welded and welded with other processes, but that's typically what's done on a big project. It's a self-shielded flux core, and it is low hydrogen too. There's a number of ways to measure the preheat. Temp stick is the most commonly used in industry because they're portable and they're actually very accurate. What's important is that the minimum temperature is achieved. In this case, if we went about 100 degrees over, it wouldn't hurt a thing. So another way to measure is infrared guns. These are common too, and these are getting less expensive and easy to use. And there's thermocouples and more precise ways. But for what we're doing today, and what typically is used on a high-rise building like this, is the temp stick. What I'm going to do is heat this area up in here and check the temperature on the back. So I'm going to put a mark on the back here, and I'm going to put another mark here, and I'm going to put a mark up in here and a mark here. And when I warm this part up, we'll keep referencing and checking and making sure the heat's all the way through and soaked into this web of this beam here and all the way through the flange and all the way down into the web of this. I'll heat that from the back side, okay? We'll come back and check it after we get it warmed up. Okay, first I'm going to get ready to light up this torch. I'm going to turn my propane on first. I'm going to just give it one full turn so I can turn it off in a hurry if I have to. And the oxygen valve gets opened all the way. It's a double seat valve, so it's important that that gets opened all the way. And it's open. I'm also going to set my pressure for about 35 psi on the oxygen and only about 8 on my propane. And we got that up to 8 or 9. And first thing I'm going to do is bleed the gas out of the lines so that we have, if there is any gas that happened to inadvertently get mixed up in the hoses, we purge that out. So I'm going to open the propane first, and I'm going to operate this torch for about 2 to 3 seconds. They say 1 second for every 10 feet of hose. I have about 25 feet of hose here. And I check my setting there, and we're still good. We're about 8. It's pretty good. And I'm going to go with the oxygen. Same thing. 2 or 3 seconds for my 25 feet of hose, and we purged our lines. We have flash arresters, we have check valves on the torch. Okay, I'm going to put my gloves on, and I'm going to come over here, and we're going to go over how to light this torch. Some people, when they light a propane torch, will actually crack the oxygen and propane at the same time. That's because they're out in the wind, or they'll lay the torch down on a steel. That works also. In this case here, in this building, there's no wind, so I'm going to just crack it a little bit and crack my fuel first and light that. Get a little flame going, just a small flame, and we're going to turn that up a little bit. And then I'm going to sneak up on it a little bit at a time. Bring that up a little more. Bring that up a little more. And here. Okay. Now I'll come over here and I'll start preheating. Just see, when I first start preheating, the steel looks like it's sweating. A little bit of moisture on the steel and condensation. That's not moisture coming out of the steel, that's condensation from the combustion on the torch, the oxy-fuel torch. I'm going to warm this steel up. And I can see already I'm getting some heat on this top piece. You want to make sure that heat soaks all the way through that flange. So I'm going to check it on the back side also. Should start to see some of those crayon marks melting in a few minutes here on the other side. Okay, I think this thing is up to temp. We'll turn the torch off now. I'm going to turn the fuel gas off first. When we're working with alternate fuels, we always turn the fuel gas off first. If you turn the oxygen off first, you get a great big flame, and if the wind's blowing, that flame will blow on you. There's not really a pop back like there is with acetylene, so I went with the fuel gas first and then the oxygen. Okay, this particular joint is preheated to above the minimum interpass temperature, and it's ready to weld on. Now we have to remember, each pass, we have to check between passes and make sure we're staying above 150 degrees. In some cases, we also have to watch the upper interpass temperature, depending on what the code says. Thanks again for watching Masterclass for ARC Magazine. I'm Carl Hose.